All right, today we're tackling something you probably learned a long, long time ago, but we're going to look at it in a totally new way. We're talking about the number line. It's a tool so fundamental, it's basically a map for the entire world of numbers. So let me just start with a question for you. Think about all the numbers you can possibly imagine. Not just 1, 2, and 3, but I mean fractions, decimals, the whole shebang. How do you give every single one of them a home, a unique address?
Because that's the real challenge, right? It's not just about counting stuff. It's about understanding this huge, ordered system of numbers. It's about seeing where they all live in relation to each other. Which one's bigger, which is smaller, and by exactly how much. And that is the problem the number line was built to solve.
So let's dive into it. We're going to explore the big idea behind this simple yet, incredibly powerful tool, a line for all the numbers. Okay, so here's the official definition, but listen to the wording. It calls the number line a useful tool in comparing numbers and understanding arithmetic. That right there is the key. It's not just a ruler, it's a tool for thinking. It makes all these abstract numbers concrete by giving them a physical spot on a line. So, how do we actually build one of these things? Well, it's surprisingly simple, but trust me, every single step is crucial for creating that perfect ordered map. Let's get into the blueprint and see how it's done. Here we go. Step 1, you just draw a straight line. Easy enough. Step 2, you pick a point, any point, and you call it 0. That's our starting point, our origin. Step 3, pick another point and call it 1. Now this next part, this is where the magic happens. Step 4, that distance, the space between 0 and 1, that becomes our master key. We call it the unit measure. And finally, step 5, you just copy and paste that exact same distance over and over to mark out 2, 3, 4, and on and on. It's simple, it's logical, and it's perfectly ordered. I really want to hammer this point home. This unit measure, it's the very soul of the number line. It's the one fundamental rule that guarantees every whole number is spaced out perfectly. The consistency of this one little segment is what brings order to an infinite line of numbers. It's everything. And you've seen that little arrowhead at the end of the line, right? Well, that is not just for decoration. It's actually a really powerful symbol. It's telling us that this pattern doesn't just stop at 10 or 100 or a million. Nope, it goes on forever. Just like the numbers themselves, the line is endless. Now, we almost always see number lines drawn side to side, horizontally, but they're actually a bit more versatile than that. Let's see what happens when we just change our perspective a little. And you know what? The rules are just as simple and intuitive. On a horizontal line, the one we're used to, numbers get bigger as you move to the right. But if you stand it up vertically, the rule just shifts. Now numbers get bigger as you move up. Just think of a thermometer. That's all it is, a vertical number line.
Okay, so we've placed all the whole numbers, 1, 2, 3, and so on. But what about all that empty space between them? This is where the number line really shows its true power. Let's start filling in those gaps. Seriously, think about it for a second. Between the point we called 0 and the point we called 1, there's a whole universe of other numbers, isn't there? You've got fractions, decimals. Where do they fit into this perfect map that we're building? This shows you exactly how it works. Let's just look at that all-important space between 0 and 1. If we divide that little segment into 4 equal parts, boom, we've instantly created addresses for 1/4, 1/2, and 3/4. And the same logic applies everywhere else. That first quarter mark between 1 and 2, well, that's just 1 1/4. It's a system for dividing up the spaces. And there it is. That's the big reveal. Using this exact method, just dividing the intervals, we can give a precise point on the line to every fraction, every decimal, every mixed number. Every single one of the numbers of arithmetic, as they're called, can find its own unique home. Nothing gets left out. So we've built it, we've filled it up, but so what? Why does this simple little line matter so much? Let's just quickly recap its power. The number line's real magic is how it lets us see relationships in an instant. You can tell 7 is bigger than 4 just by looking, because it's to the right. It helps us understand the distance between numbers, which is really the foundation of subtraction. And get this simple line is the very first step toward building things like coordinate planes and graphs. The tools we use to map out everything from city streets to entire galaxies.
And really, that's what it all comes down to. The number line takes this purely abstract concept of numbers and turns it into something we can see, something we can almost touch, and something we can intuitively understand. It creates a map where every single number has its place. And I'll leave you with this little thought. We've found a home for every whole number and every fraction. But what about those weird numbers that can't be written as fractions, like the square root of 2 or pi? If you could zoom in forever between two of these points, would you find that the line is actually full? Or are there still tiny hidden gaps waiting to be filled? Something to chew on.